Well, hi everybody. This is video number 2 in our solving quadratic equations topic. And so in this video, I'm going to show you how to solve quadratic equations in method number 2. Now, method only 1 and method only 2 work for certain situations, but then when I show you method number 3 in the next video, that's going to work for any quadratic equation that I can give you. So, while the first two are specific to certain problem types, the third one is going to work for any quadratic equation. So, you're going to have a plan B in your back pocket that you can use for any quadratic equation I can give you after viewing the next video. All right, but before we get to that, let's look here at method number 2 because it is a great method when you have certain setups like these right here on the screen. So, I have two equations for you here. I'm going to solve the first one with you, and then I'm going to give you a chance to solve the second one here in a second. So on the first one, you can probably already tell what the two roots are going to be to the equation. Of course, the two numbers that you square to get 49 are 7 and negative 7. Now, in order to show this algebraically as an equation, though, you need to remember a technique that we did probably back in pre-algebra. So if I set this up correctly, like so. Now, if I want to get from x squared to x, we probably should remember that in order to undo squaring a number, we do the square root. I'm going to put that in red, actually, so it kind of differentiates there. So those cancel out, like so. And that then means that we have x equals 7. And we also know that negative 7 is also a solution because we have to have two solutions because of the degree, right? So another way to say this is plus or minus 7. All right? So that's how we solve these little equations using square roots. And the method 2 is the square root method. So try this method on the next equation you see down at the bottom. X squared minus 169 equals 0. Okay? I'll pause for a minute and give you a chance to try it. Okay, so if you, first of all, we need to get, and like the previous method, we need to get the number over on the right side. Okay, so those cancel out, and if x squared equals 169, take square roots, and you get x equals plus or minus 13. Now, in each of these cases, I could have factored these. So, like in the second one here, I could have just kept that in the same format, used the factoring techniques, difference two squares, okay, or ABC method, factored it, got positive 13, negative 13, okay. But there are a couple of instances where this method is going to become quite useful, and I'm going to show you some examples here after I show you the method on when the square root method is going to be very helpful when you solve some of these equations, okay? On your assessment, there's going to be some problems where you have to use square root method in order to solve them. There's two of them on there that you're going to have to be able to do that with. So it's important to know all three methods because you're going to have to solve two equations minimum using each method that we talk about here. So make sure you understand how to use each method. So this is the square root method. I'm going to zoom out on this a little bit so you can see it all on the same screen. There we go. Okay. So on this method, let's go over the steps here. Okay. On this method, we want to isolate the quadratic term. Okay. So that's the squared term. All right. So if that's not isolated, like in the previous method, we wanted to get 1 set equal to 0. On this method, we want to get the x squared term or the quadratic term by itself on one side of the equal sign. So we'll talk about how to do that coming up here. And then once that happens, we want to take square roots of each side of the equation. Okay. In order to account for both solutions, make sure you put a plus minus sign before the radical expression, especially if you're not taking the square root is not a perfect square you're taking the square root of. So, for example, the square root of 13 is going to say the square root of 13. We're going to leave these in radical form. So it'll be plus or minus square root of 13. Okay? So you want to make sure that you keep that in mind. In fact, I'll write that down here so you can see it. Whoops, that's my highlighter. Like so. Okay? And I'll work examples out here in a few minutes, so you'll see how that exactly works out and stuff like that. If necessary, steps 3 and 4, these could happen in your problem, not necessarily, okay? So you might have to isolate the variable completely, okay? So if there's just one variable, not a quadratic expression, get the variable by itself, okay? And finally, oops, let's color that different color. You're going to simplify the expression under the radical, okay? So remember when we simplified radical expressions, okay, that knowledge is going to come into play here as well. So remember, square root of 8 becomes 2 radical 2, and those kind of things. Those things apply here. They also apply on the next method, so don't forget those techniques as well that we talked about earlier in the semester, okay? The best way to kind of go through this, though, is with an example. So I'm going to go ahead and do this one right here so we can go ahead and see how this method works. Most of the time, it works out pretty quickly. So on this problem right here, okay, I need to isolate the x squared term because I don't have an expression that's squared, I just have a variable. So I'm going to get the x squared by itself. So in order to do that, I need to divide both sides by 2. Okay, so those cancel out. X squared equals 36. Okay, then all I have to do is take square roots of each side. Those cancel out. So I have x equals plus or minus the square root of 36, which then is, of course, x equals plus or minus 6. So as soon as you take that square root, you want to put that plus or minus sign right there next to it so you don't forget that you have 2 solutions, because if you don't account for both solutions on your assessment, I can't give you full points for that. So make sure, get in the habit, putting that plus or minus sign before your radical right away, okay? So that's how you use the square root method to solve a quadratic equation. And it'll be counted for both solutions, positive 6, negative 6, okay? So that is just a quick way to write both of them when they're both opposites of each other, okay? So that's example 1. Now, on example 2, I'm going to get it started for you here in a minute. I'm going to pause and let you try to get it solved for yourself here for a few minutes. And then I'm going to let you finish it on your own, and you can check your answer with the answer key that I will give you here in a few minutes. Okay? Or you can check it online, or I'll provide you the answers here in just a second. I'm going to pause and let you solve this one, and then we'll talk about it. Okay, so on this one, we still want to get the x squared by itself right here. So I'm going to mark it. All right, so I'm going to get rid of these 2 x's here because they're not going to be helpful. They cancel out anyway. So I have 4x squared equals 4, okay? And then from there, it's just like example number 1. So I'm going to stop there with it, but I'm going to tell you over here the solution is x equals, I'll tell you the solution in a second. I'm going to pause, so you chance to hit the pause button, finish solving it, and then I'll tell you the solution. Okay, so I'm going to pause. Okay, so I'm going to pause. The solution is x equals plus or minus 1. Okay, so if you got those 2 values, you have the correct answer, okay? The correct roots, 1 and negative 1. Okay, let's try number 3, okay, number 3. I'm going to pause for a second, let you guys try it out. Okay, now don't get fooled on this, because if I try to isolate the x squared term, which is right here, I have to subtract 29 from each side. Okay, so those cancel out. Okay, so I have x squared equals negative 25. And here's the catch with this. We've talked about this before. A perfect square number cannot equal a negative number. So this equation has no real solutions. So we are finished. This one has no solution. Okay? So watch out for that. If you have a x squared equaling a negative number, that can't happen. So make sure you are aware of that and don't go on, because the answers are not plus or minus 5. Those are not going to work out, because 5 squared is not negative 25, and neither is negative 5 squared. So watch that. All right. Now, for the last kind of problem you can see with this topic, I'm going to work both problems 4 and 5 out because they both require a couple of things that you need to be aware of. So we're going to, first of all, isolate the quadratic term. Okay, so we're going to get that by itself. So all I have to do here is add 6 to each side. And I have x minus 5 squared equals 49. Okay, I'm going to move this down one step here so I have a little bit of room to work. There we go. Okay, now we still do the square roots. So we take the square root here and the square root here. Now here's the really cool thing on the left side. Okay, the square root still undoes the square. So we're just left with x minus 5. So you don't have to multiply that quantity out, okay, using FOIL method. You don't have to do that because the square root, when you take the square root, it undoes the square. So you're just left with x minus 5 on that side, okay? And over on the other side, you're going to have plus or minus the square root of 49. And we know the square root of 49 is 7. So I'm going to do x minus 5 equals plus or minus 7. Okay? And then, to finish it up, all I have to do to get x by itself is add 5. But when I do that, you need to be careful with this step because you need to add the 5 before the plus or minus sign. Okay? So this has to go right there. 5 plus or minus 7. Okay? Otherwise, you won't get the right roots. So make sure you put that addition step, that last step to get x by itself before your plus or minus sign. Okay? So then when you do the math, you get the correct roots for your equation. Now we're not done with this yet, so I'm going to continue this up over here real fast and show what the two roots are. So the first one, because there's two roots here with the plus or minus sign, don't forget, right over here. Okay, so we have to do 5 plus 7 and 5 minus 7. So the first one is 5 plus 7, which is 12. And the second one is 5 minus 7, which is negative 2. So the two roots for this equation are 12 and negative 2. And we can check it. We'll check one real fast. We have a little bit of time. We have a chance here to check it. We'll do it. If you plug in, we'll do 12. If you do 12 minus 5 squared, okay, minus 6, we'll see if that equals 43. Okay, well, 12 minus 5 is 7, so we're going to do 7 squared minus 6. That equals 49 minus 6, and that indeed equals 43. So it checks, okay? And the second one will also check. Negative 2, because negative 2 minus 5 is negative 7. Negative 7 squared is 49, and 49 minus 6 is 43. Okay, so they both check. All right. The only thing that makes this a little more complicated is if this radical right here is not of a perfect square number. Okay, so I'm going to show you how to do example 5, and then we're going to call this video done, and we'll work on method 3 in the next video. So check this out. We're going to do 5 here fast. Okay, same process as before. In fact, if you want to work it, I'm going to pause for a second so you can pause this and work it, and then we can check the work as we go together here. So I'm going to pause for a minute. Okay, so now you've had a chance to work it. You can check my work and see how we are. I'm going to isolate, again, this quantity, because this quantity is squared. Okay, so I'm going to do that by adding 5 to each side. Those cancel out. So I'm left with, and I wanted to do this on this line down here, so I'm going to do x plus 3 quantity squared equals 8. Do your square roots. They cancel out there. So now I have x plus 3 equals plus or minus 8. Square root of 8. I'm sorry. Square root of 8. My mistake. Solve for x. Get x by itself. Subtract 3 from each side. Remember, it goes before the plus or minus sign. So I have x equals negative 3 plus or minus the square root of 8. Now that would be great if the square root of 8 didn't simplify, but it does. So we need to put the square root of 8 in reduced radical form. So what I'm going to do is, we've done this before, I'm just going to take the square root of 8 and write it as a product using a perfect square factor. So we'll do a little scratch work over here on the side. And do right up here, okay? So the square root of 8 equals the square root of 4 times 2. That's the largest perfect square factor of 8 is 4. Square root of 4, whoops, wrong number. Square root of 4 times the square root of 2. Break it up, and then simplify. 2 radical 2. Okay? So, the final answer to our problem is x equals negative 3 plus or minus the 2 radical 2. And that one is finished. All right, so this concludes the second video, and you can do the second assignment now. And I will be back with video 3, and we'll do the last method that works for solving any quadratic equation. So if you have no restrictions on what method to use, you can use method 3 for any quadratic equation I give you. Okay? So we'll be back with the third video. Thank you very much.